Let's try to find out the characteristic roots of the following matrix. A is given to you as 2, 2, 1, 1, 3, 1, 1, 2, 2. So while finding out characteristic roots, as we previously saw, that we need to use the characteristic equation. So first of all, let us find out A minus lambda I. Now this time I will be a 3-degree matrix, identity matrix, because we have the case of a 3 by 3 matrix. Okay. Now A minus lambda I in this case will be A is 2, 2, 1, 1, 3, 1, 1, 2, 2. And we need to subtract lambda I. Lambda I will be the scalar matrix with lambda, right? So lambda on my diagonals and 0 in other places. So it will look like this. So ultimately the matrix that we will obtain will be looking like this. It will be on the diagonal, I have a minus lambda with all the elements. So 2 minus lambda in the diagonal, 3 minus lambda in the diagonal, and 2 minus lambda again. And rest of the elements will remain same. Okay, so it will be something of this sort. Now characteristic equation which we have to use, characteristic equation will be A minus lambda I determinant equals to 0, right? So the determinant of this matrix has to be 0. So this matrix has the determinant 2 minus lambda, 2, 1, 1, 3 minus lambda, 1, 1, 2, 2 minus lambda again. And this determinant has to be 0. And this will give me a polynomial. And how do we figure out what that polynomial is? Just take out the determinant of this matrix. So 2 minus lambda, I'm expanding it using the first row. So 2 minus lambda multiplied with the determinant 3 minus lambda, 1, 2, 2 minus lambda, minus 2, 1, 1, 1, 2 minus lambda out here, plus 1 into the determinant 1, 1, 3 minus lambda, 2. So this will give me, this equals to 2 minus lambda into 3 minus lambda, 2 minus lambda, minus 2, minus 2 into 2 minus lambda minus 1, plus 1 into 2 minus 3 plus lambda this time. Okay. And if you open it up, what will we get? When we open it up, so we will get 2 minus lambda into 6 minus 3 lambda minus 2 lambda plus lambda square minus 2 minus 2, 1 minus lambda plus 1 into lambda minus 1, and this eventually will give us 2 minus lambda, and here you will have a lambda square minus 5 lambda plus 4 minus 2 into in fact now I can just open this bracket, curly bracket also, so plus 2 lambda plus lambda minus 1. Okay, and this eventually will be giving me 2 lambda square minus lambda cube minus 10 lambda minus 5 lambda square plus 8 minus 4 lambda plus 3 lambda minus 3. And this turns out to be a cubic in lambda, so minus lambda cube plus 7 lambda square minus lambda 11 lambda plus 5, and this should equal to 0. That's what we're looking for. This should equal, this is the determinant equal to 0. So I have a cubic equation in lambda. So lambda cube minus 7 lambda square plus 11 lambda minus 5 equals to 0 is my cubic, and I need to find out the factors of this cubic. So we have a cubic polynomial. To find out the factors, we first of all use the hidden trial method and find out one factor. So when I put lambda equals to 1, what am I getting? I'm getting 1 minus 7 plus 11 minus 5, which essentially is 0, right? So lambda equals to 1 solves this equation. Lambda equals to 1 solves this equation. So this implies that lambda minus 1 is a factor. Okay, so lambda minus 1 is a factor. To find out the second factor, what we can do is we'll do a polynomial division. So wherein we divide the whole cubic by lambda minus 1. So I have a cubic, lambda cube minus 7 lambda square plus 11 lambda minus 5 divided by lambda minus 1. So lambda square, when I multiply with lambda square, I'll have a lambda cube here minus lambda square. So I subtract it, lambda cube gets cancelled, and I have remaining, I have minus 6 lambda square and plus 11 lambda minus 5 comes down from here. So next what I do, I multiply lambda with lambda. In order to get 6 lambda square, I need minus 6 lambda square, I need to multiply with minus 6 lambda. So minus 6 lambda square plus 6 lambda is what I get. Okay, when you subtract this, 6 lambda square gets cancelled out, and what will remain is 5 lambda, and minus 5 comes down here. And in case I multiply lambda minus 1 with 5, I will get 5 lambda minus 5, and when I subtract this, I have a 0 remainder. Okay, so we have been successfully able to get the second factor. So that means lambda cube minus 7 lambda square plus 11 lambda minus 5 can be factorized into lambda minus 1 comes common, and it gets multiplied with lambda square minus 6 lambda plus 5. If you notice, you can again break this lambda square minus 6 lambda minus 5. How? We can just do the factorization method, and with which I can use 5 and 1 as the factors. So minus 5 lambda minus lambda plus 5, and this will give me the factors lambda minus 1, lambda minus 5. So that means I have 3 lambdas. I had a cubic, I had a 3 by 3 matrix, so I had a cubic polynomial, and I have 3 lambdas. So lambdas in this case will equal to 1, 1 and 5. So that's how you find out your eigen values or your characteristic roots.